Alright students, welcome to our next lesson of our matrix unit. We're now covering chapter 5i, which is on encoding and decoding using your inverse matrices. Quick recap, last lesson we learnt about applications of your inverse matrices and using a matrix and finding its inverse. Okay, so that would be 8.5. Now if you've forgotten that, please watch the previous lesson, which was this one, to understand how to do the next lesson, which is on encoding and decoding your matrices. Now, I'll read from here. Some of you guys may have actually already come across something like this before in your everyday life, but let me read this. Info stored in a matrix can be encoded by multiplying and encoding a matrix. Okay, so some key information there that we need to know is multiplication. It's going to be important, and this encoding a matrix. Okay, the original information can be recovered by multiplying the inverse matrix. So this word here we learnt about last lesson, the inverse of the encoding matrix. So the encoding matrix, its inverse, these two are somewhat connected to each other. Okay, and we learnt last lesson that a matrix, or 2x2 matrices, or any square matrix, may or most likely will have some sort of inverse, so opposite of itself. So the encoding matrix and its inverse is important. Okay, so you're going to be using that in this lesson. Now, I mentioned before that some of you may have come across this idea of encoding and decoding a matrix. You'll find that in a lot of cybersecurity, or even in people who want to send secret messages to each other, or I would assume even when you send a message to, for example, via Instagram or any messaging app like WhatsApp or Facebook Messenger, they actually use this encoding and decoding matrices. So they change your numbers, your words, into some sort of number, and then it gets encoded using a matrix of some sort, and then it gets sent into the cyber internet somewhere, and then someone else receives it, and their phone or their message that you sent them will receive the matrix that's been encoded, and then it will get decoded using this. It sounds a little bit crazy and it might not make a lot of sense, but it is something that is used a lot in IT. So let's continue on by doing an example. Here we have a 16-digit credit card number, and it's been stored in a matrix. So here's your credit card number. No, it's not Todio's credit card. It is just a credit card number. And it's stored in this matrix. We can see that it's got 2 rows and 1, 2, 3, 4, 5, 6, 7, 8 columns. Okay. Just before I continue on, when we do this topic of encoding and decoding matrices, all of your messages or your secrets or whatever it is that you're going to encode always have to be in 2 rows. So you've got to write them in 2 rows. Whether it's like a really long message or a short one, it's got to be in 2 rows always. Okay, and the reason for that is because the coding matrix we use is going to be a 2x2 most of the time. Actually, every single time it's going to be a 2x2. We'll never do a 3x3 or 4x4 in year 11 at least. Okay, so your matrices for coding are going to be 2x2, and your messages always have to be in 2 rows. Okay, just keep that in mind. So we've got this 16-digit credit card, and we want to encode the credit card using the coding matrix. Okay, so the way we do this is we multiply both matrices. Now you might think, all right, so am I going to go M times C? Well, if you think about it, if you do M times C, so if you try to multiply these two together, it's not going to work. Why? Because the order of this is 2 by 8, and the order of this is 2 by 2. Notice how the middle numbers are not the same, and if you look, the number of rows does not correspond with the number of columns here, so it's not going to work. All right. Sorry, the number of columns won't correspond with the number of rows. All right? It's not enough numbers. So M times C is not going to work. What you need to do instead, okay, is C times M. And you're going to use this principle each time. It's always going to be the coding matrix. Okay, not enough space. Let me just move that here a bit. Decoding matrix multiplied by the message, or whatever you want to use for that, but message matrix. I'm going to call it that from now on. Message matrix, always, okay? Keep that in mind. It's going to be the coding matrix times the message matrix all the time. Because if you think about it, if I do C times M, okay, and it's going to be tricky to, actually, I'll put it here. Give me a sec. Paste it here. If we do C times M, notice how this will now work, because this matrix here, C, is a 2 by 2, and M matrix, so C times M, notice how M matrix is going to be a 2 by 8. So the middle numbers are the same, so that checks out, and the outside numbers will tell you the order of your answer, which is a 2 by 8 of some sort. Okay, so C times M is what we will use for this one. All right, so in this case, C times M, it's going to be this matrix, C. Oops, sorry guys. Matrix C. Okay, where did it go? So I don't have to rewrite it. There's a lot of writing. Okay, this is going to be annoying. There it is. Matrix C. Okay, times by matrix M, which is this matrix. Okay, so C times M. Now, you're going to complain to me and say, sir, that's a lot of multiplying by hand. Fear not, because you're not going to do these by hand. Okay, it's a lot to do. So all these questions, when it comes to encoding and decoding, use your calculators. Okay, please use your calculators for it. So I'll actually start a new document if you want, or I've already made this. It's in this matrix here. I've made it. All right. So it's going to be C times M. So what you're going to do is just multiply them together. So it's always going to be coding matrix times the message matrix. And what this is going to do is it's going to actually, when, for example, you're on PayPal and you want to use your credit card, but obviously for cybersecurity reasons, what will happen is when your details get sent, so there's my matrix C, what they'll probably do is they'll have a matrix called a coding matrix, and then they'll put your credit card in some sort of 2 by whatever, how many columns matrix, and they'll multiply them together. So C times M, and now you get a mixed up bunch of numbers that is not your credit card number. So there is the answer. So C times M, and we get this. Okay, so that is how we encode a matrix. So now, if this message or these numbers were to get sent out, if a hacker was to try and get your credit card details, they can't. Okay, because your numbers don't correspond with the original numbers there anymore. Unless, of course, if they got really smart and somehow were able to get hold of the coding matrix. Because what we'll go through next is how do we actually go back, I'll go from the mixed up matrix to the original message matrix. Okay, so we'll get into that here. So here's an example, and this is what you'll find. The letters, this is what you'll be using, sorry, in a lot of the examples in the questions, and also in your SAC and your practice SACs. Okay, so you'll use this key, okay, as a way to correspond to certain letters, okay, because the next part is going to be about decoding a matrix. So here, the letters in a text message have been converted into numbers using the following table. So A corresponds to number 1, B is the number 2, C is 3, D is 4, so on and so forth. Keep in mind that number 27 represents a space. Okay, so keep that in mind when we try to decode a message. Now, here is, for example, a encoded message. So what happens is when you encode a message, it's mixed up. You don't know, the numbers don't actually make sense when you try to actually decode it or try to correspond the numbers with these letters here. See, 68, there is no 68 here, so we don't know what 68 means. 57, well, there is no 57 there. No 49, no 32, no 131, no 41, okay? So this is a encoded matrix, or a mixed up matrix, okay? And you cannot decode it unless, of course, like I said before, you have the original coding matrix. Now, this is where what we learned in the previous lesson will come to help you. What you need to do is for this matrix, in order to decode this, you have to get the inverse of this and then multiply it with this. Okay, so you have to get the inverse of the original coding matrix and multiply it with this matrix here. So to encode, it's C times M, okay? Or so it's going to be the original coding matrix times the message matrix, but to decode, so I'll write that here. This is how you decode. You have to get your inverse of C times multiplied by, I'll write that here, sorry. So inverse of coding matrix, so inverse of C multiplied by the encoded matrix. And when you think about it, the encoded matrix is this C times M. So it's basically C inverse times C times M, whatever the encoded matrix was. Okay, so this is how you decode. It's going to be the inverse of the coding matrix times the encoded matrix. So C inverse times C times M, which is this basically. Okay, this is my remember what this matrix represents. This is the encoded matrix. And in this case, this is matrix C, and this is the encoded matrix of some sort. So we need to now decode this. So all we have to do is basically get the inverse of this matrix and just multiply it with this matrix. So to do that, on my calculator, use your CAS calculator for this, okay? Because again, you're not going to do it by hand. It's too much. Okay. And note, yes, I cheated and already did this for you guys instead of having to do it. But if you've forgotten how to make a matrix, remember, it's this button here, and then you just pick out of these four. This here is a 2x2, so I use that to make a 2x2 matrix. Yes, I could use that to actually write this matrix in 2, 3, 1, 2, but I've already done it, so I won't do that again. Same thing for writing the I think it was a 2x8. So go with this matrix because it lets you make whatever matrix you want. So we have 2 rows and 1, 2, 3, 6 columns. So 6 columns. Right, and then just put your numbers in. I've already done it for you guys, so I won't do it. So there's my C matrix. There's my encoded M matrix. So in order to do that, like I said, all you got to do is get the inverse of the coding matrix. So C inverse. On your calculator, you can literally just write C to the power of -1 for C inverse. Otherwise, you can also do get this matrix to the power of -1. Oh, that also works. So on my calculator, sorry, I'll put this in your examples here so you can see what I'm doing. Okay, so C inverse, which is that, multiplied by this matrix here, matrix M. Okay, because this is the coded matrix. Sorry, encoded matrix. Same thing. Multiply by this. And what you'll find, okay, is when you multiply those two together, that will give you the original numbers that correspond with this. So let's do that on my calculator. So C inverse, you just go C inverse, same thing as what I just did before, multiplied by, oops, make sure you press the right button, because if you actually don't do that, your cursor stays up here, and if I go multiply by M, I don't think it'll work. exactly. So you have to go C inverse, put your cursor to the right, multiplied by matrix M. And that now gives you the original numbers that will correspond with these numbers up here. So sorry, the original matrix that correspond with those numbers. So I'll put that here. And we'll figure out what the original message was. Alright, so what this message was saying is, so 13 corresponds with the letter M, 15 corresponds with O. Actually, let me space this out properly. What have we got? 14 corresponds with N, 4 corresponds with D, the number 1 corresponds with A, and the 25 corresponds with Y. So you've got the word Monday. Okay, and let's do the second row. 14 corresponds with N. 9 corresponds with, what is that there? I. 7 corresponds with G. 8 corresponds with H. 20 corresponds with the number T. The letter T. And 27 is a space. So the message is Monday night. Oh, that was the original message here. All right, I'm going to perhaps do one more example for you guys, but if you understand it, feel free to now go ahead and do the questions, but I will do one more example here. So if you remember earlier in this lesson, I mentioned that all your messages need to be in the form of a 2-row matrix, and you can have however many columns you want. So let's say my message was I am hungry. Okay, let's say that's my message. Okay, now I need to put this message in a two rows column and however many 2 rows and however many columns I want. So if I was to do that, putting this in a matrix, I could go I space A M, and I might go one more space. Actually, I'll make it 2 spaces because I want hungry on the bottom row. So H U N G R Y. Okay, there's my message. I am hungry. Now I've got to correspond those letters to these numbers here. Okay, so in terms of putting this in a message with those numbers, all you have to do is just swap the letters with these numbers. So the letter I will be 9. The space will be 27. The letter A will be 1. The letter M will be 13. And then 227. So let's make more space here. Okay, there's the top row. Next row, H is 8. U is 21. N is 14. G is 7. R is 18. And Y is 25. There's my matrix. So now I want to encode this matrix. I'm just going to use this matrix here to encode it. So to encode this, remember this is called matrix M for message. So I'm going to encode this. Remember to encode, it's going to be C times M. So it's going to be that matrix C, which is this. Matrix C, which is this. Okay, there's my C matrix multiplied by matrix M, which is this. Okay, C times M. Ignore that A, sorry guys, let me get rid of that. Okay, so there's my M matrix, just multiply them together. So C times M. Now, the tricky part is I haven't actually done this in my calculator, but I will do that now. So I've already got matrix C in here, so I'm just going to make a new matrix M. Okay, so I've already got C matrix. matrix C is already in my calculator. All right, and now I need to make a new matrix M. So to make that matrix, here I've got, remember it's always going to be in 2 rows and the number of columns will change. So I've got 1, 2, 3, 4, 5, 6, 6 again for this one. Okay, cool. So 9, 27, 1, 13, 27, 27. And I've got 8, 21, 14, 7, 18, 25. Call that matrix M. Okay, so now I'm going to encode this. So it's going to be C times M, C multiplied by M, and there is my answer. Okay, right there. So there's my encoded matrix right here. So now no one can see my message that I am hungry. Okay, but what you'll get is now after that, once you've encoded the matrix, you'll now need to decode it. So to decode, so this is to encode, remember? And this is how we decode now. It's going to be to decode, you get the C inverse and multiply that with this message matrix, which remember this was C times M. Okay, so to do that, all we have to do is decode. On my calculator, you can do your C inverse by going C to the power of -1, and that gives us the inverse of C. But remember as well, in the previous lesson, we learned about how to do it by hand. So make sure you don't forget how to do that by hand. But on your calculator, it's doable by just using your calc. So there's my C inverse right here. All right, so get this guy right here, C inverse, and you've got to multiply it with this matrix. Oops. Okay, remember this was C times M, so I have to now decode the matrix. Okay, and that means the answer, if you were to do it properly, should revert you back to this original matrix here. Okay, which is what corresponds to these letters, which will give us the message I am hungry. So if we've done it all correctly, C inverse times C times M should give us this matrix. Okay, so let's do that. So you can go C inverse, to the power of -1, multiplied by, so that's that matrix, so I can go that, multiplied by matrix M, which was this, C times M. And it should give us back to that original matrix here, which is correct. All right, 9, 27, 1, 13, 27, 27, 8, 21, 14, 7, 18, 25, and again, you just correspond those numbers with those letters here to get back to the original message of the matrix, which was, so when you put this back as a final answer, I would normally just represent it back to the original, what it was before. So I space A M space H U N G R Y. Cool. Now I hope you guys learned something here. Go ahead and do chapter 5I for your questions. Thank you.